Hey everyone, so today we're going to talk about product rule and quotient rule, which are two rules we use for differentiation. So just want to make yourself a note there. So when taking derivatives, product, that means when we're multiplying two functions together. Quotient, when we're dividing two functions together. And what are those special rules? And we kind of mentioned this briefly. This would be something like if I said take the derivative of x squared times e to the x, right? Two different functions that we can't just combine. So here's the rule for it, okay? Very important, definitely want to highlight this one. If you take the derivative of f of x times g of x, okay, our answer is going to be f prime times g plus f times g prime. So basically, derivative of the first times the second plus first times the derivative of the second. Okay, so more simply, f prime times g plus f times g prime. Now, again, this, like I said, this would be two variable functions. So we're not talking about something when this is a constant. Okay, so for example, so do not have to do when one is a constant. You guys can either write that or you could just look at this example here. If I said find the derivative of 2x to the 7th. Okay, 2 is a constant, x to the 7th. Well, we already know how to do this, right? This would be 14x to the 6th. Just use power rule. So we're talking about when it's two variable functions, so not just a constant. Okay, so let me show you why this works and why we're going to use this. Okay, so here's our y. And basically, I'll give you kind of an example that we could do by hand. So let's do x squared times x cubed. Okay, now we do know how to do this one, right? We could just make it x to the 5th and take the derivative, but I just want to show you why this would work. So again, if we're referring to our rules here, this is f and this is g. Okay, if we were to take the derivative using the product rule, we would do derivative of the first, so 2x times the regular second function, x cubed, plus regular f times derivative of the second. Okay, and that would get us 2x to the 4th plus 3x to the 4th, which is 5x to the 4th. Okay, and this should make sense to us, right? Because if I had just done this problem, last unit, you guys would have said, just make that x to the 5th, bring down the power, subtract a power, and these two guys match. 5x to the 4th is definitely the derivative. Okay, the reason that we want to take this into account, though, and here would be our no, this is what people want to do. Okay, here's a counter example. If I gave you x squared times x cubed, sometimes people are tempted to just take the derivative of each one. So, first one's derivative is 2x, second one is 3x squared, and we get 6x cubed. You'll notice this is not the same, therefore, that's kind of a good counterexample of why this does not work. So, so we're going to try a couple examples here. Definitely that highlighted blue section, you want to feel good about that by the end of this here. So we're going to try number 1 and 2 together. Okay, so take a look at number 1. Again, we're working with two functions multiplied together. So this one we'll call f, this one we'll call g. Okay, and you can either kind of jump right into this, or if you want, I'll have students or myself, I'll kind of write down the 4 pieces I need, which is f, f prime, g, and g prime. Okay, you don't have to show this work. This is just if you want to organize yourself here. I would write this as 6x to the 2/3 plus x. So make it into that power form, exponential form. And g is 4 minus 2e to the x. Okay, f prime, that would be bring down the 2/3. So 6 times 2/3 is 4, x to the negative 1/3, 2/3 minus 1, plus 1. And g prime would be 0 minus 2e to the x. Okay, so once you kind of have this set up, again, all you're really doing, if you want to think of it even in an easier way, guys, you're just going like this. These two multiplied plus these two multiplied. And it doesn't matter the order since we're adding. Okay, so we're going to multiply, typically I do f prime times g first. So these guys, 4x to the negative 1/3, plus 1 times g plus these two. f times g prime. So 6x to the 2/3 plus x times negative 2 e to the x. This would be, we could say f prime of x for this whole function. I guess we should have named it something differently. We'll say this is y prime. Okay, and you can leave it like that. You actually don't have to multiply anything together. If it was a free response problem on AP, this is fine. And definitely for me, I'd like you to keep it pretty, you can simplify a little bit, but you just kind of run into doing if you make an algebra error, then you get the whole problem wrong because you made a silly mistake with multiplying. That's kind of a waste of time. So this again was f prime times g plus f times g prime. That's where all these pieces are from. Again, you just need this answer, so you don't have to show this work if you don't want to. Sometimes people like being more organized like that. So let's take a look at the next one. Okay, the next one you'll notice, if I gave this to you last chapter, you actually might multiply stuff in. So I'll kind of show you both ways here. But let's say we're just in our mindset, we see two things multiplied together. You can definitely utilize product rule. Okay, so by the way, I meant to say this. If I gave you 2x to the 7th and you acted like f was 2 and g was x to the 7th, you would actually still get the right answer. You would just be doing a lot of extra work. But I don't want you to think product rule wouldn't work. So same thing here. If we're going to treat this as f and g, we'll write this as t to the 1/2 minus 1. Okay, we're looking for h prime of 1. So we want to find h prime of t first. So again, I'll show that little bit of work. You don't have to, but if you like this organization, that might be a good plan. So 3t squared and t to the 1/2 minus 1. Those are my two original functions. And then I've got 6t, and this would be 1/2 t to the negative 1/2 minus 0. All right, so as we write h prime of t, again, really what you're doing here, guys, is you're doing these two plus these two. So multiply f prime times g plus f times g prime. So f prime times g plus f times g prime. All right, and then your last step here, if you're feeling okay about that, h prime of 1, you would do 6 times 1, 1 to the 1/2 minus 1, plus 3 times 1 squared, 1/2 times 1 to the negative 1/2. Okay, right here, 1 to any power is itself, so 1 to the 1/2 is 1. This would get me 0, so 6 times 0 just cancels, plus 3, 1/2 times 1 to the negative 1/2. Again, this just cancels to be 1, so it'd be 3/2 times 1. So 0 plus 3/2. Final answer, 3/2. Okay, and as I mentioned, if you feel okay about that, I was just going to show you, you could do this as an alternative. It's never, I'm not going to say you have to use the product rule for this specific problem, because you actually could have done this. If you had multiplied this in, since we can multiply those two together, h of t, that would have given you 3t squared t to the 1/2, so 3t to the 5/2 minus 3t squared. Okay, and if I had taken h prime of t, 15/2 t to the 3/2 minus 6t. You don't have to write this down, I'm just showing you another method. And then if you did h prime of 1, you would get 15/2 times 1 minus 6 times 1, which is 3/2. So I just wanted to show you, you actually could do either version here, so I don't want you to feel like you had to do product rule, but it's also pretty nice, it's a nice option to have as well. So that is product rule. Okay, so again, that's when we're multiplying two functions, variable functions, and we're going to save number 3 for class. Okay, so I'm going to skip on down here to our quotient rule. So quotient rule, maybe no surprise, is we are dividing two functions. So again, two variable functions. And this one, as you can see, is a little more complicated. All right, so what we've got going on here, okay, is we've got g of x times f prime minus f times g prime over g of x squared. Notice this one is a subtraction, so it does matter what order we write it in. And I just want to mention, first of all, if this is not two variable functions, like if I gave you this problem, d dx of x plus 6 over 3, or something like that, you should simplify this to the derivative of 1/3 x plus 2, and then just take the derivative and you get 1/3. That's going to save you so much time compared to doing like this is the high function, this is the low function. Don't spend time on it if you can simplify. Same thing if you can like factor and cancel. That would definitely be a reason to use this. Or even something like, 10 over x. Well, this would be the same thing as the derivative of 10x to the negative first, which would be negative 10x to the negative second. So I just don't want you to spend time on things that we already know how to do, so don't assume if you see a fraction you have to use quotient rule, but at the same time we want to look out for two variable equations and two things that we can't easily divide, or just something that looks new, or different types of functions. So here's what I want to call these two functions, and this I use a little kind of word play on this so that you can remember it. So f, we've got f prime and f. I'm just color coding right now. We're going to call this the high function. Okay, it's on top. And then we've got the low function. So I'll do this in green. This is exactly how I learned it in high school, but it's actually a nice little trick, word trick to remember this. So high over low. Okay, so what would this be? Well, if you take the derivative of high over low function, it's low times the derivative of high, so low d high minus high, or f of x, d low, over the low function squared, so low squared. All right, so if you say it a little quicker, low d high minus high d low over low squared. It's a great way great way to remember this, and definitely a quick way to, in your head, kind of get this down. So low d high minus high d low over low squared. And again, that's talking about the low function times the derivative of the high function minus the high function derivative of the low over the low function squared. Okay, so keep that one in mind. Again, it's a nice little word trick to remember it. We're going to try out number 4 and 6 and 7 here, so want to make sure we're feeling okay about this. So take a look at number 4. Number 4, you might try to factor, and you can. The top doesn't actually factor, so we kind of give up on that. All right, so you can do the same little setup we did if you want. I kind of think it's nice to organize here. So f is, again, that high function. G I'm going to treat as our low function. Okay, so if you want to write yourself a note, this is high, this is d high, this is low, this is d low. All right, so the first, we've got 2x squared minus 4x plus 3, and our low function is 2 minus 3x. Derivative of the high function, or d high, would be 4x minus 4, and derivative of the low function is negative 3. Okay, so the order does matter here. So we're going to say to ourselves kind of the same situation here. So f prime, it says find f prime of x, given f of x. And you have it all written down. Okay, if you feel good about that whole section, we're just going to follow that pattern. Ready? So low, d high. So far I have g times f prime, or low function, d high, minus, this is always minus, high function, so 2x squared minus 4x plus 3, that's f, d low, times g prime, all over low squared, which is 2 minus 3x, or g squared here. All right, so low d high minus high d low over low squared. And that's it. Again, I wouldn't mess with it and really do much algebra here to try to simplify, because you don't need to. So I would just leave it like that. All right, we're going to save number 5. Has to do with number 4. We're going to try out 6 and 7 and see how we're feeling here. All right, finish up our notes. So you take a look at 6. We can't really simplify this, right? There's nothing we can divide out. So we just say, all right, this is f and this is g. We're going to be using that quotient rule, finding dy dt. Okay, derivative of y in terms of t. So f prime. You could also write this as, high, d high, and then low, d low. That's what these are, depending on what you want to use here. It's up to you guys. Okay, so top function is sine of t. Low function is 2 minus cosine of t. Derivative of the high function is cosine, derivative of sine is cosine. Derivative of negative cosine, well, derivative of cosine is negative sine, so this would be negative sine. So basically it just ends up being positive sine of t. All right, so dy dt, let's try it out. Okay, low d high minus high d low all over low squared. All right, so see how you feel about that. So again, it's low d high, aka g times f prime, minus f times g prime, all over g squared. And if you wanted to simplify this, you could a little bit. This would be the same thing as 2 cosine of t minus cosine squared of t minus sine squared of t all over 2 minus cosine t squared. The only reason I point this out is you can actually do a little trig simplification here. Negative cosine squared minus sine squared, if you factored out a negative 1, you would get negative 1 times 1. Cosine squared plus sine squared is 1. So this would be the same thing as saying 2 cosine of t minus 1. That whole thing becomes negative 1 over 2 minus cosine of t squared. But at the same time, guys, we don't need to do that. The only reason I bring that up, what if it was multiple choice and it ends up like this? Probably good to look out for some type of trick like that or any type of trig that might be hiding in there, but not all the time. If it's free response, definitely feel free to leave it that way. Okay, and number 7, this one I wanted to just bring up because actually it should be easier than what we've done, and I want you to notice because it's 2 divided by a function. 2 is a constant. So again, if one of these is a constant, we can probably treat this like we did before. Okay, so if we start off this problem and rewrite it as y equals, this would be 2 over 9x to the 4th, right? Square each one of these. And we can just rewrite that as 2/9 x to the negative 4th. This is not a situation where we're going to need quotient rule. And again, one of the functions being just a constant, that kind of gives that away for us. So find y prime, bring down the power. That would be negative 8/9 x to the, subtract 1, negative 5th. So if you did quotient rule and you did, the high function was 2 and d high would be 0, low is 9x to the 4th, 9x to the 4th, and d low would be what, 36x to the 3rd. Okay, you would get the same exact answer as this, but you'd be spending a lot more time than just doing the power rule. So I just wanted to point those out to you every so often. And that's going to be it for our practice. So hopefully you're feeling okay about that. Really, when you come to class, just make sure you're feeling really good. You know this rule, either like that or using this kind of acronym here, whatever we want to call it, wordplay on that. And then definitely know the product rule. Product, quotient rule, ones you should know for sure. And the rest of this will work with a table, kind of using those rules to answer some of those questions, as well as finish up 3 and 5. All right, so thank you guys so much for watching, and please let me know if you have any questions.